For almost 50 years, Voyager 2 has been traveling farther from Earth than its creators ever imagined. Launched in 1977, this remarkable spacecraft has survived extreme cold, powerful radiation, and countless technical challenges while continuing its journey into the unknown. Most missions are designed to last only a few years. Voyager 2 has continued exploring for decades, sending valuable information across billions of kilometers of empty space. Every signal it sends takes many hours to reach Earth, making it one of humanity's most distant scientific explorers. As Voyager 2 moved beyond the familiar planets, it entered a region that scientists had never observed directly. This wasn't just another part of the solar system, it was the boundary where our sun's influence begins to fade. For many years, astronomers believed this transition would be slow and gradual. They expected the solar wind to weaken little by little until it blended with the material drifting between the stars. But Voyager 2 told a very different story. Instead of a gentle transition, the spacecraft recorded sudden and dramatic changes. Radiation levels increased sharply, the surrounding plasma became much denser, and the magnetic environment shifted almost immediately. It was clear that Voyager had crossed an invisible frontier. This boundary, known as the heliopause, marks the edge of the Sun's protective bubble. Inside this region, solar wind and magnetic fields help shield our solar system from much of the high-energy radiation traveling through the galaxy. Outside that shield, conditions become much harsher. For scientists, this discovery confirmed that our solar system isn't simply floating through empty space. It travels inside a vast magnetic bubble that protects the planets from some of the most energetic particles in the galaxy. Without that protection, Earth would experience a far more hostile cosmic environment. Voyager's measurements also revealed something unexpected. The heliosphere isn't fixed in place. Instead, it constantly expands and contracts as the Sun becomes more or less active. During periods of intense solar activity, the protective bubble grows larger. During quieter periods, it shrinks, allowing more galactic radiation to move closer toward the inner solar system. This means the edge of our solar system is constantly changing. It breathes with the rhythm of the Sun. Scientists also discovered that the heliosphere is far from perfectly round. Instead, it appears stretched and distorted as it moves through the interstellar medium, shaped by powerful magnetic forces beyond our solar system. Every new measurement forced researchers to update models that had existed for decades. Then another mystery appeared. After more than 40 years of reliable operation, Voyager 2 suddenly stopped communicating normally with Earth. For mission controllers, the silence was alarming. Had the spacecraft finally reached the end of its life? Had decades of radiation damaged its aging electronics? Or had something unexpected happened beyond the edge of the solar system? Engineers immediately began analyzing every possible explanation. Hours later, communication slowly returned. Voyager's systems recovered, and the spacecraft continued transmitting scientific data. Although NASA attributed the incident to technical issues associated with an aging spacecraft, the timing attracted attention because unusual changes in the surrounding space environment had also been detected. Researchers continued studying the data, hoping to understand exactly what Voyager had experienced. Whatever the cause, the event highlighted an important reality. Interstellar space is not empty. It is a dynamic environment filled with energetic particles, invisible magnetic fields, and constantly changing plasma. Instead of silent darkness, Voyager found a region full of activity that scientists are only beginning to understand. And as the spacecraft continued its historic journey, it would uncover even more surprising clues about the mysterious space between the stars. As Voyager 2 continued moving deeper into interstellar space, scientists expected the environment beyond the heliopause to remain relatively calm. Instead, every new transmission revealed a region far more dynamic than anyone had predicted. The spacecraft's observations built on the same themes described in your uploaded script but are rewritten here in entirely original wording. The first surprise was the behavior of space itself. Many people imagine the space between stars as completely empty, but Voyager found something very different. Invisible streams of charged particles moved through the darkness, while magnetic fields twisted and shifted over enormous distances. Instead of silence, interstellar space was constantly changing. Researchers began comparing Voyager's measurements over time and noticed that the surrounding environment behaved almost like weather. Powerful waves of energetic particles would suddenly appear, pass the spacecraft, and then disappear again. Magnetic fields changed direction, plasma density rose and fell, and the conditions around Voyager never remained exactly the same for long. These discoveries revealed that the galaxy is far more active than it appears from Earth. Another mystery soon emerged. Scientists had expected the Sun's magnetic field to point in a noticeably different direction from the magnetic field of interstellar space. Instead, Voyager found that the two were surprisingly well aligned. No one had predicted such a close match. Researchers proposed several possible explanations. One idea suggested that the Sun's influence had slowly shaped the surrounding magnetic environment over millions of years. Another possibility was that our solar system happened to form in a region where the galactic magnetic field already pointed in a similar direction. Neither explanation has been proven completely. But both suggest that our local corner of the Milky Way is more complex than previously believed. At the same time, Voyager continued demonstrating something equally remarkable: its incredible durability. The spacecraft was never designed to operate for nearly 50 years. Every day, its power supply becomes a little weaker. To extend the mission, engineers carefully switch off non-essential systems, preserving enough electricity for the remaining scientific instruments. Even with limited power, Voyager continues sending information from farther away than any other active spacecraft. Every signal takes many hours to cross the enormous distance back to Earth. Each transmission represents another successful conversation between humanity and a machine traveling through the darkness beyond the planets. Voyager is also carrying something unique. Attached to its side is the famous Golden Record, a collection of sounds, music, greetings, and images chosen to represent life on Earth. Although it was created as a message for any future civilization that might discover the spacecraft, its greatest value today may be symbolic. It reminds us that exploration is about more than collecting scientific data. It is also about curiosity. It is about asking questions that no generation before us could answer. As Voyager moves farther into interstellar space, it continues revealing details about a region humanity has only begun to explore. Every measurement improves our understanding of how stars interact with the galaxy, how magnetic fields shape space, and how our solar system fits into the much larger structure of the Milky Way. Perhaps the greatest lesson Voyager has taught us is that the universe rarely behaves exactly as expected. Every time scientists believed they had a complete picture, the spacecraft uncovered another mystery waiting to be solved. Today, Voyager 2 continues its lonely journey into the darkness. Its cameras are no longer taking photographs. Its power is slowly fading. Yet its scientific mission continues, one faint radio signal at a time. Long after its instruments eventually fall silent, Voyager will keep traveling among the stars for millions of years, carrying a small reminder that one civilization on a tiny blue planet chose to explore instead of standing still. And somewhere ahead, beyond every map humanity has ever drawn, another discovery may still be waiting.